Here's where we really ought to have our flowcharting program available to us, and I wish that I'd already gotten an alternate to Lucidchart planned. So I need to nail that down so that by Monday we can start using it. In this chapter, you'll learn about the disadvantages of unstructured spaghetti code. 3 basic structures: sequence, selections, and loops. Using a priming input to structure a program. I believe we've mentioned that once, or at least I showed y'all a Sentinel loop that needed a priming input. The need for structure, recognizing structure, structuring. Okay, the word structure is appearing 20 times in a row here. All right, so what is spaghetti code? Logically snarled program statements, often a complicated mess. Now, it's pretty difficult anymore to write spaghetti code, but it didn't used to be difficult. Let me just give you an example. Please don't write this down as notes, but there used to be a program, well, there still is, a programming language called BASIC, where you could do things like this. Print, enter A, and this is not the exact syntax really. Input A, 30, if A equals 2, go to 60, 40, B equals A, 50, C equals A times 2, 65, go to 70, 60, go to 40, and anyways, kind of goofed that one up. The point being is that with these go-to statements, the code looping all over the place. Get that value, input it, and then if they typed in an A, go to 50. Alrighty, cool enough. And then C is equal to A times 2, so I guess since it went to here first, and that meant that A was 2, and now it's 4. Go to 70 and whatever. So you see how these go-to statements are letting it blip all over the logic. Well, most programming languages don't even have a go-to statement anymore to avoid this kind of thing. And it's called spaghetti code, right? Because if you try to figure out its path through the program, spaghetti. However, long time, this was really the only way to program back when, before you had higher level languages that supported the structures that we're going to be talking about now. What are the structures? If, which is known as a decision, and then loops, and then we will get to those. So unstructured programs do not follow the rules of structured logic. That little bit of code I was just going all over the place, often a complicated mess. Programs can work, but they are difficult to read and maintain, right? If I kept working at it, I'd be able to get that to work, and then when I gave it to you, you wouldn't be able to tell what it was supposed to do. Confusing and prone to error. So structured programs follow the rules of structured logic. Unstructured spaghetti code. Here's a flow chart that kind of shows what's going on, right? I'm going to catch the dog. Did the dog run away? Yeah, come back here and catch the dog. No? If not, turn on the water. Did the dog run away? No? Okay, great. Get the dog wet and apply the shampoo. Does the dog run away? Yeah. Turn off the water, catch the dog. Right. Does the dog have shampoo on? And for some reason, no. Does the dog run away? Right. So, you can see that its path is going all through it. And the logic for that might work, right? I mean, there might not be any logic errors, so to speak, but it's difficult to trace our path through it. It would be very difficult to write a program that implemented this logic using a structured programming language such as Python. So structure is a basic unit of programming logic. There's 3 of them. Sequence. One thing after another is a sequence. Selection structure. Do one thing or the other, like an if statement. If, else. If x is equal to y, print this. That kind of thing. And then lastly, the loop structure, which causes things to repeat. So any program we want to write can be constructed using these 3 structures. So the sequence structure is the easiest one to think about. It's just things one after the other, with no branching, no skipping of any task. We've done a lot of sequence structures so far. If I open up some notes from the past, right? Well, no. This from here to here is a sequence. That's a sequence of instructions. Here's a sequence too. It does that, and it does that, but oh, all of a sudden we have a loop going on. Inside the loop is another sequence, right? These three things happen in order. When the loop is done, the next sequence is done, which is that printing of that OK done triplet message. Didn't have very many notes that day. Pretty short. All right. Oops. So selection structure is a decision. You ask a question and you take one of two actions based on testing that condition, which is known as evaluating a Boolean expression. A Boolean expression is one that evaluates a true or false. Boolean math is in math where there's only two possible values in the universe, true or false, or 0 and 1. And a Boolean expression is one that becomes true or false. Here's an example of a Boolean expression. If x equals 3. Right there, that's our Boolean expression. Right there, because it's either true or false, right? And so that's why we can use it as an if statement. And if this is true, it will do the code that's indented underneath it. So that's a decision. That's a selection. Almost about time to start making notes. For reals. We're on lecture H. All right. 3 quotes in a row, so I can just start typing. Our 3 structures. And I am personally convinced that there's a 4th structure, but if we go by the textbook, we're going to call them the 3 structures. There's selection, which is essentially if. Above that is sequential, one after the other. And then the last one is looping. So a selection is a decision based on whether something is true or not. So it's a decision based on a Boolean expression. A Boolean expression is something that evaluates the true or false. Example, if x equals y. Is that true or is that false? So there's our decision. Do I want to do this? No, don't do it. Do I want to do this? Yes. Will it end in disaster? No. Do it. Anyways, these are decision structures. It's not actually structured logic for reasons I'm not going to get into, but these are decision structures, right? The diamonds. So you can have 2 different kinds of selection structures. You can have ifs and if-elses. There's actually even a third. But you have single, alternative, and dual alternative. Here's a single alternative. It's do something or nothing. If x is greater than 0, print positive. And this is not proper Python. I'm not putting colons and everything. It's not part of a real program. It's just comments. Okay, right? And then if we put a little comment at the end of here to indicate that that's the end of the structure, there we go, right? It either does something or nothing. If x is not greater than 0, it's not going to print positive. Nothing happens, right? So that's a single alternative, if. Then there's dual alternatives. Do something or something else.
if x is greater than 0, print positive, else print not positive. And then adding a comment to close our structure here at the bottom, right? So this is dual alternative because it does two different things based on whether the Boolean condition here is true or false. So if x is less than 0, it does something. If x is greater than 0, it does something else. Well, if it's less than or equal to, right? Greater than 0 prints that, and 0 or any negative value would print that second one. Two alternatives. And then there's a loop structure. Repeating actions while a condition remains true. I've used a while loop in some of our programs so far. That's a loop structure. So looping, that's the loop structure. There's two different kinds of loop structures in our language, in Python. There's while loops and for loops. What does it do? It just repeats a block of code until a logical expression becomes false. Repeats a block of code until a condition is no longer true. So while thirsty, keep drinking, right? When I'm no longer thirsty, I'm going to stop drinking. Now to keep drinking might be several steps long, right? Raise bottle to lips, pour in, swallow. That's assuming that we have an infinite water supply. But anyways, you get the idea. And then there's a for loop, but I'm going to skip what a for loop does for now. And so we saw an example of that, right, in the pass file that I had open. I wish I'd left it open. This business right here. Enter a number or 0 to stop. If my code is not broken, which sometimes it is, all right, so like if I type in 4, tripled is 12, 5, tripled is 15, 6, tripled is 18, 9, tripled is 27, 0 to stop. Okay, done tripling. It was able to repeat that stuff until I wanted it to stop via this loop. The loop is dependent upon this Boolean expression here, this condition, just like an if statement. Like if it said if n not equal to 0 and did all that stuff, then it would do all that stuff once. But since it says while n not equal to 0, it does all that stuff, and then it comes back and checks again. Is n still not equal to 0? And if it's still not equal to 0, it repeats. And so back in olden days, this would have been implemented something like this. 10, input x, 20, if x equals 0, go to 50. And 30, do something with x, right? Y equals x times 3, 40, print y. I forgot to get the new version of x. I forgot to make room for this, so you see that my line numbers are getting smaller and smaller while I remember to this. Go to, well, here I could have just done a go to 10, and that would have done the business. So then 50, print, done. This is doing the same kind of business. Input x. Now if they type in 0, we want to stop. So it goes to done. But if they didn't type 50, then calculate the triple value of x, print out the triple value of it, and then go back to start, right? That's a loop. You can perfectly implement a loop like that using go-to statements, using spaghetti code. But it's a lot easier, makes a lot more sense, a lot less error prone if we have the keywords that let us do it like this. Input x, while x not equal to 0, y equals x times 3. Don't know when caps lock got turned on. Print y, you know, and then maybe an end while little comment, and then print done. Right. Same business. No line numbers. You know, some people actually like the idea of go-tos. They think that, you know, that makes perfect sense, and then they kind of wish that the other languages supported it. But the advantage of this kind of code right here is that there's no way for anything to sneak inside and execute a line in the middle here. Like, you know, we could have line 200 here that said go to 30, right? And then so for some reason, way down in the bowels of the program, we get to a certain point and it's supposed to jump here and start to do all that stuff. Well, we flat out know that's never going to happen here, right? It's all sequential, it's all ordered. The only time this code's going to get executed is when the, you know, code pointer reach that point, and then that happens to be true, right? So you're absolutely sure of the structure when you write it like that, when you avoid spaghetti code. And thankfully, our programming language pretty much forces us not to write spaghetti code because it gives us these structured keywords like if and while. So the sequence structure, just do one thing after another. Thump, thump, thump. The selection structure. If this thing is true, do one thing. If this thing is false, do the other. Now that happens to be a dual selection structure, right? Because it does something or something else. If this line drops straight down, that's a single alternative, right? If something's true, do it. If it's not true, don't do anything. So dual alternative ifs contain two alternatives. If some condition is true, then do one thing, else do the other. Single alternative ifs, let's do one or the other. The other is called the null case. That's a situation where nothing is done. If employee belongs to the dental plan, then take $40 from their pay. We don't even need an else clause because nothing is going to happen if they're not in the dental plan. So that's called the null case, but I'm never going to use that term again once I pass this slide. Right? The null case is just that it didn't do that. Right? It's nothing. Do something or nothing. And so here's a single alternative if. If they're part of the dental plan, remove $40 from their pay. Otherwise, don't touch their pay. Don't do nothing. A loop structure is something that repeats while a condition remains true. That's the loop body, also called repetition or iteration. As long as it keeps repeating, that's called iterating. I'm iterating through the loop. Let's go ahead and actually text something into our code that will honestly do something. I'm going to end my comment section with the 3 quotes. And I'm just going to set a value, good old temperature example. X is equal to 80 degrees, or temp is equal to 80 degrees. And if temp is greater than 100, quote, print, parentheses, quote, it's too hot, end quote, end parentheses, and then I'm going to add a comment that says end if. The comment is just indicating the close of the structure. So that was an example of a single alternative if. The above is an example of single alternative if. And so when I run it, is it going to print too hot? Well, temperature is 80. Is this a true case then? Is temperature greater than 100? Somebody just blurt out the answer so we can go on. If temperature is equal to 80, is the temperature greater than 100? No, not at all. So it's not going to do that alternative. It's going to do the null case, which is nothing. All right, so let's write a dual alternative. Why don't we check to see whether it's evenly divisible by 2? I don't know why I care if the temperature is evenly divisible by 2 or not. But if temp modulus 2, percent 2, equals 0. In other words, if you divide it by 2 with no remainder, it's an even number. So if temp percent 2 equal 0 colon print parentheses quote even number end quote in parentheses. Back tab all the way against the margin. Else colon print parentheses quote odd number end quote in parentheses, and then I'm going to close my structure with a comment, $end if.
Dual alternative, right? If something is true, print out that it's an even number, else print out that it's an odd number.
And sure enough, it is an even number. Alright guys, I need to find out exactly how crippled we are on Lucidchart. So I'm going to pause the recorder, and if somebody would log into Lucidchart with their school account